In this video, I'm going to explain how to answer multiple choice questions based on the topic of electric fields. We've got two questions and I'm going to show two methods for each question. Before I start the methods, I'll pause for about 5 seconds, which will allow you to pause the video so you can have a go at the question yourself. So question one. Okay, so first of all, looking at what we've got here, we're talking about potential, we're talking about distance. So identify the formula we're going to use, which is this one. So the first method that we're going to do on this is we're going to notice that we've got our variables here. All of this is constant, so we've got the same charge and everything else is constant. So just get the variables on one side here and all the constants on the other side. So we can say, because this is constant, whatever the potential is multiplied by the distance is going to be constant. So V1R1 is going to be V2R2. So the potential at this distance and the potential at this distance. So we're going to substitute in the values we've got. So we've got 45 volts at distance R, we've got 50 volts at 1.5 meters closer to the charge. And just multiply out and solve it for R, which comes out as 15 meters. Method 2. Same starting point here, but what we're going to do now, we notice all of this is constant, so we're just going to write it as V is equal to a constant times 1 over R, so it comes out as this. And then we substitute in, so we've got 45 is whatever the constant is divided by R, and we can solve it for K. And then we put in the other one, so we've got 50 volts at this distance. Again, solve for K, and we get this. Because they're equal to the same constant, we can just equate the two and solve for R, and it comes out as 15 meters. Is answer D in this case. Question 2. So the first thing here, what we're going to do is we've got this initial situation, we're going to be changing the charge by adding Q to each charge, and we're going to change the separation. So Q becomes plus 2Q, and minus 2Q becomes minus Q, but we've got distance D there. So the first method we're going to do, on this one, we need to identify the formula we're going to be using. So it's to do with the electric force, which will be this formula here. And we're going to write it down for the original situation where we've got Q and we've got minus 2Q. If we multiply these together, we end up with minus 2Q squared, distance D. And we're going to do the same for the second situation here. We've got the same multiple here because we've got plus 2Q and minus Q, multiplies out to be the same thing. We've now got twice the distance. And remember, we're going to be squaring the distance, so 2D becomes 4D squared. And what we notice is the only thing that's different between this and this one is the expression for distance. So we end up with a quarter because we've got, it'll be 1 over 4D squared. There we go, and that's answer A. Method 2. So a slightly different approach to this one. So what we're going to do is we're going to get all the constants on one side, the variables on the other side. So we can see that we've got, we're looking for the force, we're changing the distance, we're changing the charges, everything else is constant. So we can say that what we've got in situation 1, we've got the force at distance D. Again, when you multiply out the charges, comes out as minus 2Q squared is equal to the new force multiplied by the new distance squared. But again, we've got the same product of charges on the bottom. And we've got twice the distance, but when we square that, that comes out as 4D squared. And we can just cancel out all the common terms. We've got minus 2 squared there, we've got D squared and got D squared there. So it comes out as F1 is 4 times F2. So therefore, that's the answer, which is A again.